In this video, we conclude our discussion on Chapter 5, where last time we went over inflation effects. In today's video, we'll go over some inflation data by considering the GDP deflator as well as the inflation rate. With this in mind, beginning with some preliminaries, thus far, we have developed the GDP deflator as well as the inflation rate as our measures for the price level of an economy as well as how the price level is changing over time. Additionally, we have examined the micro as well as macro level effects of inflation, and we have defined price stability for our performance goal of full employment. Now what we'd like to do is to put some context to our measure by examining some data. So, as we did with the unemployment rate and GDP, to proceed we will use St. Louis Federal Reserve data, in which, with respect to the GDP deflator, we'll use nominal GDP and real GDP for the United States in order to construct the GDP deflator, where with respect to this data set, it will be annual data from 1948 through 2021, as we have been using before. And with respect to real GDP, our base year will be 2012, just as it was when we were examining GDP in Chapter 3. And in terms of how we will examine our data, it will be observational, as we've done in the past, in which we'll look at some run plots and we'll look at some scatter plots. And here what we seek to do is look at some run plots to see how the price level of the economy in the US is changing over time. We will then examine the average value of the inflation rate in the United States, from which we'll determine if the inflation rate is pro-cyclical, acyclic, or countercyclical. Then we'll conclude by examining if the unemployment rate is related to the inflation rate, given that in our definition of full employment, we are tying the two together. With this in mind, let us proceed by examining the GDP deflator in the United States over time by using a run plot. We have a run plot on the right, in which years is going to be on the horizontal axis, and we have our price index value on the vertical axis. Since the base year for real GDP was 2012, that means with respect to our GDP deflator, our price index base year is also going to be 2012, in which it has a value of 100. And as mentioned in the prior slide, the GDP deflator was constructed by taking nominal GDP divided by real GDP, all scaled by 100 for each year in our data set. Or with respect to what we can observe, we see that as time progresses, the GDP deflator in the United States seems to be roughly increasing throughout. As is, this is about all we can say with how the data is presented, so the way that we'll proceed is we'll transform the data into percentage change form. That is new minus old, divided by old, all scaled by 100 for each observation, where observe when we transform the GDP deflator into this percentage change form, this will give us precisely that of the inflation rate. So looking at our new run plot on the right, we have the inflation rate, but once again, years is going to be on the horizontal axis, and now we have percentages on our vertical axis. And in terms of the inflation rate, when we carry this transformation out, as we have seen in our prior transformations, doing so, we lose one observations, and we are now looking at 1949 through 2021. And we see that there are fluctuations in our data set, as we've seen when we've applied this transformation, where in terms of these fluctuations, it seems to be that the inflation rate is fluctuating around 3%. And something worth of note as well is we see around the early 70s to early 80s, there seems to be a spike in these oscillations in which it does obtain its maximum value of somewhere around the 10% mark. Now, since we've transformed the GDP deflator into the inflation rate, this transformation gives us access to summary statistics where we can confirm that the fluctuations in the inflation rate are around 3.11%, or that the average inflation rate value in the United States is 3.11%, which is just shy of our price stability value of an inflation rate of less than 3%. Furthermore, in terms of these fluctuations, we see that the typical bound between these fluctuations is going to be 3.11% plus or minus 2.28 percentage points, given that it's its standard deviation. And in terms of our goal of price stability, although on average the United States is just shy of it, if we look at one standard deviation in the form of 3.11% minus 2.28 percentage points, we'll be capable of meeting that price stability goal within the United States. And lastly, with respect to our fluctuations, although most of them are captured within this range of 3.11%, give or take 2.28 percentage points, we see that the minimum value is minus 1.97%, which occurs in 1949, and that the max value for these oscillations is 10.5%, which occurs during that range of around 1973. So now that we know that the GDP deflator is increasing over time in the United States, that the inflation rate on average is 3.11% in the United States, and it's just shy of our goal of price stability, but within one standard deviation is capable of meeting our goal of price stability. Now where we'd like to proceed is by determining if the inflation rate is pro-cyclical, counter-cyclical, or acyclic. So as we've done before, we'll look at our percentage change run plot by having the inflation rate with the percentage change in real GDP and see what we can observe. Then we will look at a scatter plot. So beginning with our run plot, we have the inflation rate in red, and then we've added the percentage change in real GDP in blue. In terms of these fluctuations, we see that the inflation rate is capable of moving with real GDP and against real GDP, in that we see then that the inflation rate has some evidence of being acyclic. Furthermore, given these oscillations, we see that the inflation rate seems to have more tame fluctuations than real GDP, which we can further evidence by looking at our summary statistics and notice that the inflation rate has a standard deviation of 2.28%, while real GDP has a greater standard deviation of 2.61%. So, given this observation of inflation rate being able to move with and against the percentage change in real GDP, let us now turn to our scatter plot and see what we see. In terms of our scatter plot, we have the percentage change in real GDP on the horizontal axis, and we have the inflation rate on the vertical axis. In terms of what we observe, we see that there's a mostly horizontal cluster of points, which further gives us evidence that the inflation rate seems to be acyclic. And something worth of note as well is we see that as real GDP growth increases, the variability of the inflation rate seems to be decreasing as well and condensing towards its average value of 3.11%. However, based upon what we see in terms of the horizontal cluster of points in our scatter plot and in terms of the run plot in which the inflation rate is moving with and against the percentage change in real GDP over different periods of time, what we'll conclude is that the inflation rate is acyclic in this data set. With this in mind, lastly, what we'd like to do then is conclude by examining the relationship between inflation and the unemployment rate, given that our full employment goal, that is the lowest rate of unemployment compatible with price stability, ties these two variables together, in which both of these variables were found to be problems in an economy. In that with respect to unemployment, at the macro level, unemployment means out of labor resources, which means producing below potential. Where with respect to inflation, unexpected inflation corresponds to uncertainty, where with uncertainty comes about a decline in economic activity. So the way that we'll proceed is we'll look at run plots with the unemployment rate and the inflation rate together, and then we'll look at a scatter plot, just as we've been doing before with respect to a variable and the percentage change in real GDP. So starting with our run plot, we have years on the horizontal axis and we have percent on the vertical axis. In terms of the inflation rate, we have this in blue, and in terms of the unemployment rate, we have it in red. Where some initial observations, we see that there's going to be periods of time in which the inflation rate and unemployment rate are moving against each other, but there's also going to be periods of time in which the inflation rate and unemployment rate are moving with each other. So based upon these initial observations, we can give some initial insight in that the two variables may be unrelated with one another. Now, moving on to our scatter plot, let us see what we see. In terms of our scatter plot, we have the unemployment rate on the horizontal axis, and we have the inflation rate on the vertical axis. Where we see as the unemployment rate increases, it seems to be that the inflation rate is not very responsive in terms of a clear direction of an increase or a decrease, and there's a lot of variability in terms of the inflation rate. So with this in mind, this leads us to conclude that the inflation rate and the unemployment rate are on average unrelated, which coincides with our initial insights in terms of what we saw in our run plot. However, this may not be the entire story. If instead, let us focus on looking at a shorter time horizon in our scatter plots and see what we can see. So here we have our initial scatter plot that we had before, in which we're looking at all of our data from 1949 through 2021. And below, we're introducing a new scatter plot with the unemployment rate and the inflation rate, in which we're looking at shorter time horizons, in which we're only considering 1960 through the early 70s, where in our initial scatter plot, we concluded that the two variables were unrelated with one another. However, if we look at our new scatter plot, in which the unemployment rate once again is on the horizontal, and we have the inflation rate on the vertical axis, we see that there is a clear inverse relationship between the two variables that is capable of shifting. And that here from the 1960s, we see that as the unemployment rate is decreasing, it's very evident that there's a nonlinear relationship in which the inflation rate is increasing as a result, in which there's also a shift in which this pattern then repeats itself, and that as the unemployment rate is decreasing, the inflation rate is increasing, then this relationship shifts again once more, and we see that relationship of the unemployment rate decreasing, and we see that the inflation rate is increasing. Now, this short-run relationship that would conclude that the unemployment rate being inversely related to the inflation rate was initially discovered by A.W. Phillips when he was looking at some wage and unemployment data in which there was an inverse relationship between the two when looking at UK data, where this idea was then extended by Paul Samuelson and Robert Solow in the 1960s looking at inflation and unemployment data in which they saw that there was an inverse relationship between unemployment and inflation, particularly in the 1960s, which is this initial curve here, and that this relationship was capable of shifting, which was later extended upon by other economists as well. And this idea of the Phillips curve itself is something that we will talk about in later chapters as well. So based upon this information in terms of long-run and short-run relationships, what we have then is that we'll update our conclusion that in the short run, there is an inverse relationship between the unemployment rate and the inflation rate, in that as unemployment increases, the inflation rate will decrease, while in the long run, the two variables are not related with one another. So with this in mind, where we'll pick up in our next video is we'll use our measures of the unemployment rate, inflation rate, and GDP to examine growth in an economy.